not a lot of people are talking about how to teach the basics of AI. Everybody's talking about how to bring AI tools into the classroom and use those, in the best case for tutoring or study guides. People are being creative, but not like, what does it mean to make a curriculum that people could touch them and think about what they are?
Welcome back to My Robot Teacher. I'm Sarah Sank.
And I'm Taiyo Inoue.
Our guest today, Eric Van Dusen, teaches in UC Berkeley's newest college, the College of Computing, Data Science, and Society. It's home to Berkeley's most popular course, Ep08, Foundations of Data Science, which is the backbone of their wildly successful data science major. Now, Taiyo, I'm going to ask what I imagine some of our listeners are thinking. This is a podcast on AI and higher education. Why are we talking about data science?
Okay, word cell. So data science is a mix of math, stats, and computation, which is all about working with data and learning from data. And when you get right down to it, AI models like ChatGPT and Claude and Gemini are really just massive statistical models. So in an intro data science course, you'll get exposed to baby versions of how these AI models are created. We're going to spend some time in the first part of this episode talking about how data science is actually a really good foundation for learning about AI. But we also wanted to bring Eric on because we think the data science program at UC Berkeley could be a model for how higher education should be handling teaching AI.
Now, I can't count the number of times that I've heard you and our other colleagues get all lyrical about this Data8 course.
Oh my God. I love Data8. I actually taught a version of it recently, and the magic of it is that it's a complete course in a box. The textbook, the code, the infrastructure, it's all open source and free for students. And it's got this ethics-infused curriculum, which is built around real-world scenarios.
So that's huge for access. But then, in addition to this massive foundations course, we're going to be discussing these connector courses, which are these discipline-specific spin-offs that complement those foundations with courses in other disciplines where students get to apply what they learn in that intro to data science course to the stuff they're studying for their majors. So as we'll discuss in the episode, we think that this can be a kind of prototype for how universities might teach AI going forward. As we've said before on this podcast, things are changing so fast, it's hard to keep track of where we are, let alone where we're going. But we think interdisciplinarity, teaching this across disciplines, embedding it within disciplines is really, really crucial. And if we're serious about AI literacy in higher ed, I'm pretty sure at least we need something different from the conventional academic landscape where 1,000 silos bloom.
So if you're wondering what AI literacy could look like as a truly hands-on interdisciplinary project, Berkeley's data science program is a really compelling model. We'll spend the first part of the episode talking a bit about that.
And in the second half of the conversation, we'll turn to AI directly. Eric is taking the same open source, hands-on philosophy that he's using in the data science courses and applying it to AI.
Right. In particular, he's using small language models in his teaching. These are models which are small enough to run on a laptop, which lets students tinker with the parameters and actually see how these language models work.
And we've been thinking a lot lately about why, if we're going to call it maybe AI studies, whatever that looks like in the coming months and years, why it needs to be interdisciplinary and how we can move beyond just using AI as a study buddy or, in the worst case scenario, a cheating machine, and how universities can build the infrastructure to support classrooms today. So with that in mind, here is our conversation with Eric Van Dusen.
Eric, do you think it's creepy to tell somebody that you've done a ChatGPT deep research prompt about them? Because depending on your response, Eric, we'll tell you that we've done a deep research prompt about you or not. So choose wisely here.
Yeah, this is just this weird time where you're like, is anybody, what thoughts are new? What thoughts are not AI thoughts? Like, we write the questions for the podcast in the AI. We write the answers in the AI. Everything is confusingly interrelated with what the models are producing.
Well, you should know Gemini called you a principal architect of scalable and equitable computing infrastructure for data science pedagogy. And we were wondering, how does it feel to be enshrined in the LLM canon as such a badass?
I might have to put that on like a business card and print little pieces of paper that these tokens resulted from. No, that's great. It is creepy, but it is just sort of where we're at right now.
So before we get into how you teach AI, can you tell us a little bit more about why this data science foundations course is such a big deal?
Sure. I mean, I say there's a lot of people who need to learn Python and need to learn to code, and there's a lot of people who need to learn statistics and inference, and this is just a great starting point, a great platform. They took like the best teacher in computer science and the best teacher in stats at Berkeley and let them just like make a new course together where they brought some amazing practices. It was right about the time that this idea of Jupyter notebooks for teaching and then a Jupyter hub for teaching was getting created. So like there's some co-creation amongst multiple things. And so they made a fresh curriculum. It boomed to be the biggest class at UC Berkeley. My estimates are about half of the undergrads at UC Berkeley take Data8. And then through this collaboration that Taiyo mentioned, we have it at something like 25 community colleges and 5 CSUs right now. So we're like in a really, healthy growth path. It's taking a lot of things like ethical concepts of where's the data coming from. It's really motivated by teaching with vignettes and scenarios and going for student engagement by giving them meaning and not just like learning math. And I think importantly, it scaffolds really well. Like you learn little elements that go on and progress, and it sets you up, either to take those skills into your other social science or to follow up and become a data science major.
And so you've taught these connector courses, right, in the Berkeley Data Science program. These are complementary courses that are really hands-on, data science focused, and tailored to particular majors. But can you tell us a little bit more concretely about what you do in those classes?
That's how I came onto the team. I never have taught Data8. It's still something that remains to be done for me, but I got hired as a lecturer. I built a connector course for myself on international development. That's who I was somebody who was doing international development. Then I did another one on open science, sort of one-off cool classes based on Jupyter teaching and learning, building sort of new problems all the time, every week. Then I built one on economics and data science, and that one I teach, I'm in the 8th or 9th offering of it right now. The idea of a connector course is like data science is great. People are engaged as this like beginning way to teach and learn. But let's go out into the domains. Let's go out into the departments and let's build curriculum that's really about a subject or a topic. I also relatedly led a program called Data Science Modules. Let's just go into people's existing classes and let's swap out a homework they might have with a Jupyter homework and get them touching code in a place they might have been touching a spreadsheet before. So the connectors were a program that ran in an innovative entrepreneurial way. Let's build some exciting new curriculum. And I was sort of part of that. And then now there's in a maturity phase where the engineering department, the physics department, the environmental sciences, legal studies, they all have a connectors course that sort of takes students that want to go into that field and is like, oh, you took Data8, here's the bridge over to our field.
Sounds amazing. Can you give us some more examples of crossovers between data science and non-STEM fields?
Yeah, absolutely. Like one of our best collaborations was with the social justice classes. They're called American Cultures. It's a Berkeley unique requirement. I mean, now we're going statewide ethnic studies, but Berkeley has had this American Cultures requirement for years. And I worked with those projects, and they were like, students were in a class to do a social justice exploration. But these professors were like, let's put data in their hands and get them to ask tough questions. One was like the data set from the implicit bias project, where people would take this implicit bias test online. Behind the scenes, that data was available. There was one where like students went out in the neighborhood and went block by block and like said, what does this block look like along a bus line, a transect of Oakland? Then you could go get the census data and be like, what does the census data say about this block? Projects like that. There's one about prison realignment in California in the Supreme Court case that said you have to empty out, the state penitentiaries, and people got moved to county prisons and people got furloughed. That data set, we let the students play with that data set. Prison overcrowding went from like 200% to 130%. So their class is talking about, mass incarceration and having prisoners come talk to the students. But then there's an exercise where the students get to see like how crowded the prisons were and how crowded the prisons still are. Stuff like that. Like I love those projects and I love those spaces, entering those spaces where people don't want to code and don't want to see data. And can you like scaffold it and make it friendly and make machine learning be something that's like a useful tool for continuing a discussion.
Mm-hmm. I got to say, I haven't taken our colleague Ariel Setniker's data science training thing, and I think she works with you, right, Eric? Or it's something like, it sounds like these module-based things that you've been doing.
Yep.
And I think the revelation I had was, I had no idea there was so much storytelling involved. Like I thought I didn't care about numbers, and actually this is incredible. And so now I've integrated a little bit of it into a class I'm going to teach in the spring. Taiyo and I talk a lot about how great interdisciplinarity is. And I'm realizing I'm curious to know, it seems like you think that too, but why? Like if somebody, interdisciplinarity was really hot in the 90s. I know a lot of people are like, ugh, interdisciplinarity's in again. What is great about interdisciplinarity? Like why should a lit professor be incorporating a data science module in their class?
Boom. I don't know. I've always been interdisciplinary my whole career, was like everything that I ever did. I love learning and I love different topics and I love different perspectives, and how cool to be at a university where there's all these different perspectives, and how cool to be able to take, different perspectives on history or social science or literature that make life richer. And, information shouldn't be siloed. Information should work across. I mean, crazy topic that data science itself is very interdisciplinary, right? There is a core thing that's data science, and we can get all into like models and training and stuff like that. But all these applications are like, if you don't know some biology or some economics or something, like you're not telling the story, you're not doing the work, right? It's really interdisciplinary applications. You're like a fundamental part of it.
Mm-hmm.
So speaking of interdisciplinarity, I'm a pure mathematician. And when I taught a data science class for the first time, I realized I kind of had to rethink basically everything. Pure math is a Platonic, very theory-first enterprise. You start with definitions and axioms, and you let the world emerge from those. Whereas data science kind of flips all of that. Data science begins with the world, the chaos of the universe, with its messy observations and irregular patterns. And then it asks what kinds of structures might explain them. And so teaching Data08 was kind of in many ways an Aristotelian shot straight to my Platonic heart.
Oh my God, you see why we're friends, right? Well, back here on Earth in the 21st century, I am interested in these connector courses as a bridge between disciplines.
Yeah. I got really passionate about the connectors. They hired me to do outreach to the next faculty and the next faculty. And then I was running professional development sessions, being like, hey, faculty, come join our project about building connector courses. And that's something that I'm still doing today. This like professional development, running the national workshop on data science education, running these learning lab workshops that became this like, skill building, community building, taking professors where they're at and being like, I can meet you with interactive computing wherever you're at, wherever you're comfortable, I can come meet you there.
I'm wondering if you can explain just in very basic terms what it is you're doing like on a day-to-day basis in these classes.
Yeah. So one thing I want to think about is just breaking the paradigm of the textbook, right? So you're in what's basically like a browser tab. There can be an explanation of what you want the students to learn pedagogically, then a little bit of code, not like a giant amount of code, just like a few lines of code. Read in the data set, show me the columns or something like that. And then the output of that will also be on that browser tab. You're not making a web page, but you're making this sort of thing that the students are seeing in this familiar space, the Chrome tab, they're like browser tab, and they're seeing little bits of code that actually run. That's the thing we're doing in the background is we're making this infrastructure so that this tab can run little bits of code. But then you're including in this space, like you teaching the students something and leading them towards somewhere. You're giving them a chance to just write a few words of Python that do something, and then giving them that instantaneous feedback. They get to see the graph or the result or the regression or the hypothesis test all in the same place. And you can sort of do a modicum of setup at the teacher side, or there's some that's like the engineer side, and then there's the teacher side, and everything's like super easy for the student.
So basically what you all are doing is intertwining exposition and code all inside a Jupyter notebook.
Yeah.
Explain to me, what is a Jupyter notebook?
Oh, it's really cool open source, zero cost platform for intertwining traditional text with computation. So for example, you can have a Jupyter notebook that explains the concept of the line of best fit for some data set, for example, but then immediately follow that up with a code snippet, which will load a data set and then compute and display the line of best fit. So it's this incredible way of making ideas that you find in data science come to life in a way that a traditional textbook just can't do.
So you're not just like reading something and then looking at an example that you're reading, but it's like, actually, here is an example. You get to try it yourself. You get to learn by doing.
That's right.
This is the idea of Data8. You're winning from day one. I'm going to set it up so that the student goes in there and they're like, I'm winning, I'm still winning. And they're going to be psyched to come back the next day and like keep winning. There's also a step, Sarah, where when you see it done live, the professor is teaching in the front of the class with the projector, and they're running their thing, demoing like that they're writing a word or two of Python. And every student in the class can have the same notebook open and running a live version of the same notebook. So when it works well, the students are like, okay, I'm going to see the shooting percentage for Steph Curry. Let's check LeBron James or something like that, where the student can change the Python code and see the instantaneous result. And there's a really nice, engaging pedagogy there.
And so this is the kind of thing where in an econ class, you might look at economic market data or something like that. Or in a pre-med class, you might look at something related to biology or medicine or drug efficacy.
All of that. Yes. Perfect.
See, this is what I think is so interesting about this as a pedagogical model. Like on one hand, you're talking about giving students a chance to understand something, potentially alienating like code by tinkering in real time, like Taiyo says. But what really interests me is this applied element. Like you're really taking opportunities to build on students' interests or to build on what they already know for their majors, maybe to apply it in different disciplinary contexts, right?
Yeah, exactly. I think by framing and showing the application of artificial intelligence to something that students are already deeply interested in, you breathe life into the subject and you make it immediately applicable. You show the value of these systems for our students' lives.
In addition to this work with data science, you've also been teaching courses where you get students working with generative AI. And again, in this very applied, hands-on kind of way.
Yeah, I've seen you talk publicly at conferences about small language models, which contrast with large language models. Can you say a little bit more about SLMs and how you can use them in an educational context?
Yeah, this is the work that I'm, staying up late at night coding right now. Something I'm really excited about. I don't know where it's going to come out, but I have a couple of talks and a couple demos. So if anybody's listening who's interested, reach out. I'd be happy to be in a conversation about this. Large language models that, these foundation models we know about and we query every day, trillions of parameters or 100 billion parameters, right? Then they make ones with 30 billion and then 7 billion and then 1 billion. And then they can what's called quantize those and they get smaller and smaller to where they could be about a gigabyte, right? So what I'm hoping to do is with this Jupyter Hub setup where we're already teaching Data8 is I'm going to have it just there ready for the students. And these are what's called the model weights.
For listeners who aren't yet familiar with what parameters and model weights mean, I wish I could remember where I saw this. It was in a Substack or Medium post. And the metaphor that they used was one of those big audio engineering mixer boards. And basically, if you think about parameters, those are all of the knobs that you have. So imagine a keyboard with 3 keys you could play hot cross buns on. But one of these major synthesizers with thousands of knobs, you could mimic the sounds of an entire symphony. interdisciplinary. And so think about like that is what the parameters are. And then the model weights are like where those dials, where those knobs are tuned in. And this is where I get fuzzy on it, Taiyo.
Yeah, I mean, the model weights are just numbers, right? They're the particular values of the parameters in the final model. And they're obtained via this training process, which is a kind of massive brew of linear algebra and multivariable calculus, and which iteratively updates this number as vast swaths of data are consumed. And like Eric says, the big LLMs that you're probably familiar with, like Claude, ChatGPT, Gemini, etc., have been trained on an insane amount of data, like basically all of the information on the internet.
Then they can make sort of distilled, smaller versions of that. There are many of them in the public domain in a place called Hugging Face. Hugging Face is just this website where people put up the models so that other people can check them out and try them. This is a really active thing in the AI development. People want the feedback of other members of the community on their model, and they want to test them against benchmarks and see how people like them.
Are these things that are trained on, like you're giving it a very niche data set to train on? Or?
That's something I would get to at a more advanced. In the first case, I would just go and be like, what's the latest? You can look up and like, what's the latest really good one that's a small size? Llama, Phi, Quen, DeepSeek. All right, there's these different ones that are like, made for this like toy Matchbox car version, right? But download that. You can do that on your local computer. And for teaching, I just thought it would be cool to see if we could do it on Jupyter Hub so the students could walk into class with not any setup.
Right. And just to clarify for our audience, that Matchbox car version, basically you're dealing with something that you can put into a live Jupyter notebook without needing a supercomputer on the back end to make it work.
Yes. And then there's these other parameters where you can change like the temperature or the number of tokens or like, how long the response is. So you can learn to Pythonically interact with things. You can also open them up. It turns out that this is a billion numbers, right? Just like a very long number is what the model weights are. So starting to think about that. What are layers? What are layers in a net? What is it like to open it? And just be like, there's nothing magic. Basically, there's a file with a billion numbers in it. And so it's still magic. Like, I don't know, like when does it stop being black box magic? Because it is still black box magic in some sense. But I guess, Taiyo, my idea is like, could interacting in a Pythonic way where you're, simply passing tokens in and out, can that be sort of like a way to like a Lego-based way to like teach and learn about what an AI model's doing? I have been in a lot of forums lately where people are talking about AI in higher education, and not a lot of people are talking about how to teach the basics of AI. Everybody's talking about how to bring AI tools into the classroom and use those, in the best case for tutoring or study guides. People are being creative, but not like, what does it mean to make a curriculum that people could touch them and think about what they are?
I guess I'm wondering, like, what's the first thing, like the first lab you'd give or like the smallest, simplest demo that would produce that aha moment about how an LLM actually works to somebody who's like totally non-adept, asking for a friend?
Yeah, so probably that one is like word prediction, like what's the next word in this
sentence?
Oh, good job, Taiyo.
And then this thing is just really good at prediction. And so it's a bunch of weights that's like guessing what the next word is. I think that's sort of one of the first things. I guess a second one that I've been working on is sort of the concept of tokens. Like we're sending tokens in and we're getting tokens out.
Again, for listeners who are unfamiliar with these terms, tokens are basically just words or chunks of words.
This is The Economist, Eric, but there's something about the efficiency of the tokens. Like, how much does it cost if I give the model 1,000 tokens, please help me plan my trip to Thailand? And then it's going to give me 10,000 tokens back. And implicitly sort of like, am I willing to pay for a certain rate of conversion? How much is the company willing to pay? And how much is our society willing to pay if we need to make new nuclear reactors or dam new rivers? Like those embedded costs in like token translation are like something that I'm trying to build a mental model around.
So it sounds like you're saying this is a way that we can talk about the actual cost of various models. Like how much energy does a prompt actually use? Or how much compute does a company actually pay for behind the scenes?
Yeah. Sam Altman has this quote about like the cost of people saying please and thank you, right? Like how many billions of dollars is he spending on people saying please and thank you?
Interesting.
Another one that's come up for me in the last day, it's ending everything that it answers you with like, would you like me to? Right? Right? It's always asking a question about the next prompt, right?
Yeah.
And that's like from internet, that's engagement. That's like eyeballs and keeping you there and keeping you sucked in, right? So there's not like, I answered your prompt, now go around about your life. It's
Right.
like, let's keep talking. It always ends with like this question, right?
Oh, that's so interesting. Wait, are you saying that that is something that it learned in training off of how internet engagement works? Or is that something that...
Yeah, the companies have, for whatever reason, made it so that at every time it's going to prompt you for the next thing and prompt you for the next thing. That starts out, that's a great question, Sarah. And then the last thing it says is, would you like me to make this into a summary for you? Or, there's always like a, let's do more.
I'm always saying, thank you, no. Instead,
I know,
I'd like to do this.
That's my default as well. Like,
No,
that's
thank
okay.
you. But I would like to move on to something completely different. So we've heard a lot about fears that human skills will erode as students offload work to AI. So we're curious to hear what you think are the foundational skills for your students. If AI can effectively handle the basics, then what becomes the new basic skills that students need to be responsible for?
Yeah, I got in an argument about this at OpenAI yesterday where I was like, you're like, kids got to learn some math. Like, we're not ready to be like, don't learn math. People are like, don't learn coding is like a thing. This is this conversation. But the same people wouldn't be like, throw out the calculus textbook, right? I think you need to learn some coding. I tell the kids in my class, don't use large language models just to straight up cheat. Use them to help you learn to code and learn some basics of code. So I think you should learn like Data 8 and Data 100 and learn to do those things at recall with them in your mind. Like you need to learn some math at recall in your mind. And then from there, like, as you get to higher level things, use the scaffolding. What do we need to learn? We need to learn like statistics and inference. Like what's a hypothesis test? What's a distribution? What's random? Why sampling is an approach? Like we need to learn those basic concepts. I guess computational thinking is what the Data 8 tagline is, computational and inferential thinking. So I think people need to know how to break problems into steps, in coding a lot of like how to build a function, how to, make something that's specific to the case that you're doing, but general to handle a few exceptions. Like there's a lot of like thinking computationally that, and it's 2025, like who knows, but like right now, if the role of the, human being is to debug code, like that's what I'm doing when I'm vibe coding. I'm fixing lots of problems in the code. Like it doesn't work the first time. And so I need to know a bunch about how the code is worked and, packages and dependencies and sources and I need to steer the code to do things for me. And I need to figure out how to debug things. And then clearly like something about ethics, like there's so many, ethical issues that you're going to have to face that like if the people in the machine aren't part of like an ethical reflection on what the machine's doing, we really need to make sure that people have a foundation and like how to ethically think about the processes that they're engaging in.
I want to say we're all public higher education people on this podcast right now. So one of the big questions that we've been thinking about is how do we as a system, the CSU, the UC, the community colleges, take on AI? It seems like for data science, Berkeley has done quite a lot to solve the access problem. They're using open source Python and open source Jupyter notebooks to platform Python. There's even computing structure that infrastructure that Berkeley has built out and has made available to, for example, the CSU. I've certainly taken advantage of that in my courses, and to all of California's higher ed institutions. But we know at the same time that with AI and deep learning, that there are massive, sometimes like $1 trillion infrastructure projects that are either in progress or on the horizon that to build out the infrastructure needed to train and run inference with frontier LLMs. And these kinds of investments are, at least right now, seemingly impossible for the state of California and for public higher education. One way that it seems to me that the CSU and the community colleges have responded is by entering into public-private partnerships with OpenAI and Google, respectively, to provide access to things like ChatGPT and Gemini for everybody in those systems at a massively reduced cost, by the way, relative to the consumer-facing product. Do you think this is the right way of going about doing things? Because this was massively controversial, at least in my experience, among my colleagues in the CSU.
Well, I want to break it into two things. What I see is a lot of faculty freaking out that AI just broke higher education. And there's no, like, the way I've been teaching my class my whole life with a final paper, I can't do that anymore, right?
Right.
And then there's some, I like 10, 20% maximum, let's say 10% of faculty that are like, it's awesome. I redid my class and I have them doing this really cool thing where they work with the model to do the homework and redo their schedule and get career advice. And it's better than ever before because me and the model are better than I was before. And this is going to be great. You're like, and I met a bunch of those people yesterday. I don't think most of us have redone our classes and redone all our assignments yet. Like the vast majority of people are sort of lagging behind, being like, oh yeah, I hope they don't cheat so much they don't learn anything.
Nailed
so
it.
let me say, like, I think that's happening, right? And that's part of your debate about the CSU having the, big agreement with OpenAI. It's prodding people to move into the future that is now. I think we need to support people to modernize their classes. I'm not really that guy, but there's a huge hole and it's not good enough. Like this podcast is part of that. And you could imagine like people at every center for teaching and learning helping faculty be like, okay, you can't just make an essay anymore. You need to make this like exploratory and you need to get good at prompting the model to help you do the research and, yes, let's teach teachers to teach those skills. That's not Eric's comparative advantage to opine on that. The other part to say, like, other part of our pitch should be, this thing is happening in California, right? The whole world is watching this, like, disruption happen, and the headquarters of it all is in California, right? So there's also just a compelling case of, like, we are, if not the whole workforce, like a chunk of the workforce, we're training a chunk of the workforce that's going to go there and be like, come on, guys, tech titans, like, help us, care us, hey, Nvidia, we could use some of those A100s for teaching too, right? and hey, big tech, like, give us some credits for teaching that aren't just like access to the foundation model like everybody else, but that's like, give us tech platform, give us teaching platforms, right? I think that the state, the governor's office could definitely, and the statewide systems could be like, let's build what we're already doing, in this Cal iCore Cloud Bank computational infrastructure. Let's build a really nice learning test bed. Let's put some small models on there. Let's give people what is trust and safety, what is bias. We could make a really awesome teaching sandbox with millions and not billions. And we could make it in this federated way. What's cool about the open source thing is a really awesome way to make it federated. So like everybody with a CSU login could get into the AI sandbox and teach the class, We're all like about like building this curriculum for AI literacy that maybe we're like a year or two behind on. But, I want to make something like AI, the AI sandbox where you go and touch the model.
Wait, I want to pause on this phrase, touch the model. It seems like there's a couple of ways you can figure out how an LLM works. One of them, at the most basic level, is prompting it with the explicit intention of getting a better idea how it works. So like testing out what different prompts, what outputs you can get, right? And that's like a very, very superficial level. Then there's the sense of being able to like go in there into a small language model and mess with the temperature, say. Like go in and turn the temperature up or turn the temperature down and seeing in real time how the responses get more or less weird and random. And that can make a concept like temperature make sense to a student, kind of in the same way that years ago when I was teaching like how algorithms worked in search and had students Google the same thing sitting around in a classroom and they all got different results. And that blew their minds like back in 2014.
Right. When I think of touching the model, I think of opening it up, looking at the insides of it, and then crucially tinkering with that model. Like Eric said earlier, opening up the file, you will see billions of numbers. But then you can mess with the numbers and see what happens. Maybe the model collapses, maybe the model gets better, but maybe the model just gets weirder. You don't have the computational infrastructure to do that when you're messing around with a large language model because too much computational power is required. But you can do that with small language models. Because they are small, students can get in there and interact with the guts of the model, interfacing with the internals of it. And that's not what regular consumers of LLMs see.
And maybe not every CSU student does it, but it could be like anybody who wants to learn a little bit of Python, anybody who wants to take Data8, like after they take Data8, they could come in this AI sandbox and like interact with models. So I think we could build it, Taiyo, and some combination of like donation, goodwill donation from industry and, statewide infrastructure and then scalable stuff. We're also working really awesomely with UC San Diego, and they have a project on like public infrastructure where people at CSUs can buy a GPU and plug it into this thing, but then they're building over time a public cloud, right? It's a national research platform. And so what happens is that the CSUs and the UCs are all connected on really good fiber. Like that, the fiber connecting it's in place. So if we could add, computational capacity in a disaggregated way, but in a federated system that's going to be able to be accessed by people.
Wow. So we're sort of making a pitch. Hey, OpenAI. Hey, Google. Anthropic, if you're listening, Meta as well. And
Nvidia.
I guess, Nvidia. Duh. Especially Nvidia. If you've got GPUs to spare, look no further than California public higher ed, okay?
And no, let's say, and trust us. Like we're gonna make awesome stuff, and we're gonna be better at training people. Like believe in us. Don't. The worry is that the Google, Microsoft will be like, oh, go over here and get the certificate in our platform.
Right.
Yeah.
And you're like, no, I think you need to trust us that like kids learning at CSU and community college is an important step. And you got to give back to those institutions. I saw a slide yesterday and I didn't remember it, but it's something like 40% of the people on ChatGPT are under 20 or something like that.
Oh, wow.
And then you're like, the kids are all using it. The people in the workplace are not using it enough, right? And so can we also just build curriculum that's like how to get your boss to become more efficient, or something, where you're like, that's legitimately like what's happening right now,
That's genius. I don't know why we didn't think of that earlier. There should be like a life skills course for that.
If we just do it as like you're saying, like a consumer thing where you're like, oh, the kids are going to know how to plan the trip to Thailand, whereas like their parents are going to read a book, a guidebook, that's not really going to get us the productivity gains and the,
Yeah.
It's much more about like, can we teach the young people these skills to be like power users and think about the architecture, what's inside it, because it's rapidly evolving, so you need to learn about the tooling if you want to be like the next thing that's coming and the next thing that's coming.
Do you think that there's something at odds with like the incentive structure there? It's like if people really learn, like you said, they touch the LLMs or the small language models and they learn to build something new, that doesn't really do Google any good necessarily.
Yeah, but like, let's not go consumer, Sarah. Let's go somebody coming from a CSU STEM track is going to go not necessarily work for Google. They're going to work for a medium-sized enterprise that needs to modernize some part of their productivity by, getting this special sauce from the AI revolution. Maybe they're a farm, maybe they're, a factory or something. So we want to train people to be customers of Google or large language models, but like for applications, right?
Mm-hmm.
Let's go back to connectors and domain knowledge. And you're like, let's get AI knowledge, but then go back to like, I'm going to be part of the biotech applications of AI.
Right, right.
And I'm going to train that student to be able to think about how the tools work. And then when they're out in the workforce, I don't know their application yet.
Right.
And it's not that they're just customers themselves of Google.
Yeah. Mm-hmm.
We're training the engineers of the next generation.
Yeah.
And this is the engineering tool.
So if you did have a message, well, you've spoken about the faculty who have just sort of sworn off AI and are almost in a frothy outrage about the entire technology. Is there a message that you would want to deliver to those folks to try to convince them, perhaps, is it fair to say, perhaps more optimistic point of view around AI in education?
Yeah, I would really love it if there was awesome people at Center for Teaching and Learning kind of people that would be like, here's ways to adapt your assignments. Here's ways to adapt what you're doing. There's like, let's go back to Blue Book exams. Let's go to oral exams. We have a new exam system that's like on a lockdown browser in a lab. Like we are in some ways moving back to traditional modes of assessment. But let's be clear, assessment was broken before AI,
mm-hmm.
right? And we were all like needing to change the way we did assessment before AI came. And it's just more glaring now that AI is here. So like we all need help, how to make assessment better. I had a great anecdote yesterday. I met this guy and he's like, so I go between the two models. I go in the deep notebook LLM. I say, here's my textbook, here's my lecture notes. Make me 1,000 multiple choice questions. Then I take those 1,000 multiple choice questions over to ChatGPT and I say, answer these 1,000 multiple choice questions. It gets 90% of them right, 10% of them wrong. That's going to be the exam, the 10% that it gets wrong. I was like, that's genius.
Oh my God. That's incredible.
But anyways, I think I'm making a joke here, but let's say
no, but that's
it's hard
serious.
to make infinity exam. Like mastery learning is like, you should have infinity exam questions and you should have the capacity to do infinity grading.
Right.
Everyone should be able to retake it as many times as they want. There should be a new test every day if you want, right? That's mastery learning. And that's why I don't do it, because I don't have the bandwidth to do that, right? There's a chance that like if I got into it and I want to spend time, like, this is something like make infinity exams that randomize themselves and grade them very quickly, or, make them into like, answers that can be quickly graded. That sort of thing could be really helpful to moving people to mastery grading that weren't moving to mastery grading. Can we move to flipped classroom? Probably it's going to help with that, right? Can I generate the material that you're going to do at home that's super tailored? Like take this lecture, make a podcast out of it. That tool's totally there. You're like, oh, I didn't have a chance to make the lecture recording. Now the tool's going to make the lecture recording. There's all sorts of things like this where the stuff we were supposed to be doing with our teaching already, the tools can help us do that. We need help. We need somebody to help us do that, I made a custom GPT. I would love to show you how to do that. There's really, like, how many people have made a custom GPT? Like 5%, right? So my stuff's all in the public domain. Again, OER, Taiyo, it's kind of funny. So I can make a public version of making a custom GPT where it goes, gets the notebooks from a public GitHub, gets the slide decks from a public Google Drive, and it makes the training data. So I can be like, hey, only answer based on the stuff from my class. And if you have like a textbook, maybe you shouldn't like upload that textbook. But because it's my own like public domain textbook, I can do that, right? So anyways, I made, a custom tutor for my class. It's out there. I don't know how much they're using it. I'm going to gather data on it. But, this is the Bloom's 2 Sigma thing where you're like, if we had individualized tutoring, we could really improve things. Like it's conceivable that the LLM is the individual tutor, right? And the other thing that's funny is the project they're working on at Berkeley is when you're watching a lecture video, there's a chat window that you can ask questions about what they're saying in lecture, but it knows exactly what they're talking about and where they are in the lecture, right? So it's like doing this like time-stamped training of the model, right? So a lot of kids are taking college online by watching videos. Like people that sign up and go to Berkeley and pay full price prefer to lay in bed and watch television of their college education. But if we can bring this kind of tool where they're like engaged by asking, and they're like, asking questions or clarifying things while it goes, maybe we can improve the quality of that form of education too. Like there's all these aspects that we can improve the quality of our instruction with. It takes work, it takes time, people are taxed, like will we all do that work? But I don't want to be Pollyanna, but I want to be like, if you wanted to put the time in, there are ways to make your instruction better.
Yeah, that's great.
I wonder too if at a time when we have to be making, building in more intrinsic motivation for our students, I worry about what it looks like to them when there are so many people who are like, I will not be changing what I'm doing, or I will just be going back to blue. I will be going back to a time when I think, the halcyon days of blue books, as opposed to thinking about modeling an opportunity to learn from one another and develop new skills. And it's like, if we can't do that, then what are we doing here?
Eric, thank you for saying that we can't throw away math just yet. That means I'm gonna have a job in the near term. So thank you for that. Really appreciate that. But really, this has just been a really wonderful conversation. Thank you so much for sharing so much about your understanding of data science and about artificial intelligence. This has been really great.
Awesome. Great conversation. Great chatting with you guys.
One of the things I admire so much about Berkeley's data science program is how hands-on and interdisciplinary it is. And it really gets me thinking about what education in AI should look like. And if we tried to mimic Berkeley's model, well, one of the core things that they did is they have this core class. They call it Ep08, Foundations of Data Science. What would a Foundations of AI class kind of look like? What kinds of things would be taught? I imagine things like how a large language model works, for example, would be a core competency, but also things like prompt engineering, how to assess and critically assess the outputs of, for example, large language models, understanding the potential for hallucination, having the discernment to separate slop from really valuable outputs. These are the kinds of skills that I think we want our students to have when they're interacting with artificial intelligence. I'm not at all settled yet on exactly what should go into such a class. This is a really hard question, but I think it's one that we have to tackle as educators.
Right. And it's a question, I think it's funny, in what are we at, like almost 10 episodes now that we've recorded of My Robot Teacher, where we initially set out to think about what does AI literacy look like? It's like, well,
Right.
Still thinking about it. I don't know.
Still don't know.
I mean, it includes, as we've talked about in the series so far, everything from like values in a particular disposition, metacognitive skills, right? But also things like info literacy, critical thinking, creative thinking, computational thinking was a phrase that Eric used. And, I'm super passionate about general education and always thinking about, why the requirements that we have are there. And I go back and forth between, like, on one hand, thinking about that this sort of like testing of here's what an English course, and you need a math class, and you need a natural science class, and a physical science class, that model that's been around for a really long time, what it might look like to totally shake that up and think about, to use that phrase, computational thinking. Like if you had to classify everything, all the disciplines in terms of like different types of thinking, I think you might have a much more like interdisciplinary or transdisciplinary approach. Like computational thinking, that's not owned by a single discipline, nor is creative thinking owned by a discipline. And it might be like, what would it look like to have a class on creative thinking that wasn't a creative writing class, but might be like creativity in art and engineering and other types of problem solving? I wonder too, thinking really concretely, like what the takeaways are for, practically speaking, what's possible right now in higher ed, where it feels like things are sort of stuck. I've had a lot of colleagues tell me that they feel like this is the first year since, the great big release of ChatGPT 3 years ago that everybody is suddenly listening and everybody is suddenly like, we have to change. And I think that data science program at Berkeley is so inspirational because it's so young. Like, I don't think we got into this in the episode, but I was reading more about it, and it seems like it was like a nascent program right before the COVID pandemic, and then pretty much instantaneously just exploded in its numbers. And then now they have to actually like do multiple graduation ceremonies to graduate the number of students in the major, which is super cool. I think it's inspirational as a model of like, yes, change is still possible in the 21st century in public higher education.
Oh, wow.
And what if we think a little bit more about what models, like, is this a model that we could use elsewhere?
Yeah, that's incredibly inspirational. You're right.
We're really excited. In the past few episodes, our community has really started to grow, and we've met so many fantastic people at neighboring institutions, at institutions far away. And it feels like now is a time, it's really daunting, but it's also a time when so many brilliant people are putting their heads together to try and solve these problems in front of us and think through them together. And I think, at a time when there's a lot of doomer stuff about people outsourcing their cognitive labor, I think we really need to think about the importance of human communities right now and thinking through and puzzling through things together. So please, if you've been enjoying this podcast, share with your colleagues and friends. We rely solely on word of mouth to spread. So we would love to keep this going as long as we can.
Drop us an email at myrobotteacherpod@gmail.com.
We might even respond to it now that it's winter break time. Thanks for listening. My Robot Teacher is hosted by me, Sarah Sank.
And me, Taiyo Inoue. And it's produced by Edit Audio.
Special thanks to the California Education Learning Lab for sponsoring this podcast. If this episode got you thinking, please pass it on. Share it with a colleague, a dean, or that faculty listserv where people won't stop talking about AI.
See you next time.